Mechanical set retrievable packers. Mechanical set retrievable packers are one of the most widely used packer designs in workover and recompletion operations. They rely entirely on mechanical forces transmitted through the tubing string to energize slips and compress the sealing elements. Because they do not require hydraulic chambers or internal pressure to set, they are simple, robust, and easy to retrieve, especially in vertical or moderately deviated wells. They can be set using any of the following mechanical actions. 1. Compression set packers, weight set packers. These packers are activated by slacking off tubing weight. How they work. 1. The packer is run in whole with the slips retracted and seal element relaxed. 2. Once the packer lands at the target depth, the driller slacks off weight. 3. This downward force compresses the seal element against the casing. 4. The lower slips bite into the casing and anchor the packer. 5. The compressed rubber element creates the annular seal. Advantages. Simple mechanism. Gravity plus tubing weight. Very reliable in straight vertical wells. Ideal for single-zone isolation. Failure and risk modes. If insufficient weight is applied, the packer may fail to fully energize. Excessive slack-off before setting may cause premature setting. Debris or scale on casing wall may prevent slips from gripping. 2. Tension set packers, upstrain set packers. These packers require pulling upstream tension to activate. How they work. 1. Packer reaches depth in the unset condition. 2. The driller picks up the tubing, putting tension along the string. 3. Shear screws or J mechanisms release the slip system. 4. The packer sets and anchors as the seal element compresses upward. 5. The driller maintains slight tension to keep the packer energized. Advantages. Excellent for thermal wells where tubing expands, SAGD, steam wells. Good option for deep wells where tubing weight is large. Less risk of premature setting during RIH. Failure and risk modes. Requires continuous tension. Tubing relaxation or thermal growth may unset the packer. Temperature cycles can cause packer to release unexpectedly. Not suitable for highly deviated wells where tension transfer is inconsistent. 3. Rotation set packers. These packers are set by rotating the tubing clockwise, most designs, to engage slips and compress the element. How they work. 1. Packer is run to depth. 2. Driller applies right-hand rotation. 3. Rotation drives a slip cone upward or downward, design dependent. 4. Slips expand into the casing wall. 5. Further rotation compresses the sealing element. Advantages. Eliminates dependency on weight or tension. Very predictable set in vertical straight hole conditions. Useful where other packers may set prematurely. Failure and risk modes. If torque cannot be transferred, deviation, doglegs, buckling, the packer will not set. Excess rotation may cause thread backing off in the tubing string. Scale or corrosion can cause partial setting. Why these packers are popular in workovers. Mechanical set retrievable packers dominate workover operations for the following reasons. 1. Simple, robust construction. No hydraulic chambers. No pistons. No control lines. No setting balls or pressure cycles. Fewer failure points during rig operations. 2. More reliable in vertical wells. Mechanical force transfer, weight, tension, torque, is strongest in vertical wells. This makes mechanical packers ideal for workovers, reentries, multi-zone recompletions, temporary isolation jobs, straddle installations. 3. Easy retrieval. These packers include a mechanical release system, often involving J-slots, shear screws, straight pull release, quarter-turn release, left-hand rotation to unseat. When retrieving, the driller applies the release action and pulls the packer free. Hydraulic set packers are sometimes harder to release due to scale plugging the hydraulic chamber. Mechanical retrievables avoid that risk. 4. No hydraulic system equals fewer leak paths. Hydraulic set packers rely on hydraulic chambers, O-rings, pistons, fluid pathways. Any failure causes incomplete setting, unintended release, leak paths across the packer. Mechanical packers avoid these issues entirely. Field example, realistic scenario. A workover crew is preparing to isolate a lower water-producing zone in a vertical oil well. A compression-set retrievable packer is chosen. The well's vertical weight transfer is excellent. Required isolation is temporary retrievable design preferred. No hydraulic lines are available. Mechanical set is ideal. During RIH, slight buildup of scale is observed when tools bounce at tight spots. When setting at depth, packer requires 40,000 pounds slack off. Slips engage smoothly. Test holds at 2,000 psi. Packer integrity confirmed. This step avoids having to use a hydraulic set packer, which could fail due to scale blocking the hydraulic chamber. Brief explanation. Tension set retrievable packer, field example. A tension set retrievable packer is used when the well has deviation or when compression. Weight cannot be reliably transferred. In this field example, the tubing is pulled upward at setting depth to apply approximately 50,000 pounds of tension, which activates the packer's internal mandrel, expands the seal element, and forces the slips to bite into the casing. Once tension is maintained, the packer provides full annular isolation. A 1,500 psi pressure test confirms integrity. This method avoids the failures often seen with compression set packers in deviated wells where weight transfer is poor. Brief explanation. Rotation set retrievable packer, field example. A rotation set packer is ideal in a vertical well where torque can be easily applied. After reaching setting depth, the tubing string is rotated 1/4, 1/2 turn to the right, engaging the packer's J-slot mechanism. This causes the slips to anchor against the casing and compresses the seal element to isolate the annulus. Despite casing scale, the slips set correctly and sealing is achieved. A 2,000 psi pressure test confirms packer integrity. Rotation set packers are simple and effective in vertical wells, but avoided in deviated wells due to torque loss. Common mechanical set retrievable packer failure modes, field reality. 1. Scale preventing slip engagement. Casing scale deposits may stop slips from biting. Packer fails to anchor. 2. Corrosion or worn slips. Slips cannot grip. Packer slips downhole or fails under differential pressure. 3. Seal element swelling. Incompatible fluids, brine, completion fluids, aromatics, can overswell rubber, cause hardening, prevent proper sealing. 4. Mechanical release failure. J-slot or shear screws may jam due to sand, scale, cuttings, casing debris. Packer stuck in hole milling required.